Hi everyone, Ms. Trutowski here. We are going to be doing focus notes through a video today. So make sure that you have your note sheet in front of you and a pencil. And I want to go over the fire expectations. You guys know these. We do them almost every day, and you know the expectations. So make sure that you are quiet and calm during this video. Make sure that you are listening to the video and taking notes. Make sure that your AirPods are away and your Chromebooks are closed. So if you are someone that has your AirPods in and your Chromebook open, please close them right now so you can be focused and show integrity. And then make sure that you are taking focus notes, but also like copying things down, but also making sure that you're comprehending the information. You're not just copying and kind of like shutting off your brain. And then feel free to ask questions. And then lastly, make sure that you have a growth mindset and be respectful to our guest teacher today. Okay, so we're going to go ahead and start to label. Make sure you put your name on the top of your notes. And then today's date is the 13th. We are in algebra, and you are in either block 2 or 4, depending on when you're watching this video. The learning target for today is going to be learning target 1-7. We're still going to be learning about exponent properties. Specifically, we're going to learn about the 0 and negative exponent properties. So go ahead and fill that out. Now we're going to move on once you get that done. And I want to talk about the 0 exponent property. Okay, so I sort of talked about this yesterday and the day before, but the 0 product, sometimes you're going to run into something that has a 0 exponent, and we're going to have to simplify that. And there is a property that goes with that, or a rule, a shortcut that says any number that's taken to the 0 power is going to equal 1. Now that just the only thing that it's any number except for when a is equal to 0. But basically think of any number that we can think of, 1,000,000, 5, -2. All of those taken to the 0 power is going to equal 1. So let me explain why that is. The first explanation is kind of like looking at patterns. So if you have some terms like powers written in exponent form, like 3 to the 4th, if you were to type that in your calculator, and I'm going to do that over here, 3 caret 4, that's going to give us 81. Now again, if you ever want to do a power button, you push that caret button. It's right below the clear button. So we get 81. That's 3 times 3 times 3 times 3. Now let's do 3 to the 3rd power. So if I take 3 to the 3rd power, again, it's repeated multiplication. 3 times 3 times 3, we get 27. That's already given for us, so we can move on. 3 to the 2nd power is 9, and then 3 to the 1st, there's just one of them, so it's going to be 3. Before we type in what 3 to the 0 power is in our calculator, I want us to look at some patterns. Look at what's happening from 81 to 27. And then look at what's happening from 27 to 9, from 9 to 3. Feel free to raise your hand if you want to share or pause the video. But what I want you to see is that we are dividing by 3 every single time. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So you can predict what the next term is going to be. We are going to divide 3 by 3 and get our next term. And you can see all of the exponents do go down by 1. So it follows with this pattern. 3 divided by 3, that's 1. If you want to just prove it on your calculator, 3 divided by 3, that's 1. And then also you could always test it and say 3 to the 0 power, that is 1. So it works out. So that's one way to show you or explain why anything to the 0 power is equal to 1. And you can do that with like any number. If you wanted to do -5 and then work your way down. If you wanted to do 1,000,000, if you could do that same process. So again, as the exponent decreases by 1, the product is divided by 3. So then that's where we get this 3 to the 0 power is equal to 1. Another way to look at this, and this is what we talked about yesterday, it's called the quotient property or quotient of powers property. Do you remember when we learned that when we divide x or powers that have the same base, what you do is you just subtract the exponents. So if you see 3 minus 3, that's 0. So basically 3 to the third divided by 3 to the third, that's 3 to the 0. Well, if you were to think about that, remember we talked about whenever you divide a number by itself, it's going to equal 1. Like 5 divided by 5, that's 1. 100 over 100 is 1. So then you would agree that 3 to the third over 3 to the third is equal to 1 because the number divided by itself is 1. Well, using that quotient property we talked about yesterday is when you subtract the exponents, we do get 0, 3 to the 0 power. So anything again to the 0 power is going to equal 1, and that would work for any number. And also you would notice, even this part, if you were to expand out 3 to the third, it's 3 times 3 times 3 on the top and the bottom. Those all cancel, and then what we're left with is just like 1 over 1, which is 1. Okay, so that brings us to a bunch of examples, and then I think this is going to be like the fun part for you. We just proved that any number, like all of these numbers, anything to the 0 power is 1. So if we were to evaluate all of these, our answer will be pretty dang easy. It's going to be 1. So -7 to the 0 power is 1. If you want to prove that with the calculator, just type it in. It does include parentheses, so we can include that. But -7 to the 0 power is 1. 43 to the 0 power is 1. 1 to the 0 power is 1. So they're all 1. Is that nice? Okay. Let's move on. If you have any questions, let me know. We are going to now talk about one more property, our final property, the negative exponent property. So this is our 6th one we are learning so far. So we did 4 yesterday. We're doing 2 today. The negative exponent property says, so basically, if you ever run into a negative exponent, what mathematician or what the laws of math say, it's that's not completely simplified. We don't like having negative exponents. So what you need to do is you need to rewrite it with a positive exponent. So if you see here, we have a to the negative n. All of these can be replaced with numbers, but if you have a negative exponent, what you want to do is you want to rewrite it so it has a positive exponent. I want you to notice is how this gets dropped down into a denominator and it becomes positive. Okay, so before I explain before I tell you or give you the shortcut way, let's explore that. So I have kind of a blank table here, and I want you to fill this in. 2 to the 4th power, 2 to the 3rd, 2 to the 2nd. Now, you might need a calculator, you might not. Once you get to these negative exponents, don't write anything in because I want to show you the pattern here. So 2 to the 4th, think that's 2 times 2 times 2 times 2. Well, you could probably do that one in your head, but if you want to double check, you can always use the calculator. 2 to the 4th power, that is 16. Okay, so we got that. We get 2 to the 4th power is 16. 2 to the 3rd power, that's 2 times 2 times 2, which is 8. Again, if you want to prove it on here, use the calculator. That is 8. It is not 6. It is a common mistake. People multiply them. All right, we could do that one in our head. 2 squared, that is 4. 2 to the first power is 2. And then we just learned that anything to the 0 power is 1. Or now let's look at the patterns now, or let's actually talk about the pattern. So, and I also want to talk about something. Exponents, the definition of exponents, they really are like repeated multiplication. So an exponent is like repeated multiplication. Taking 2 to the 4th, that's 2 times 2 times 2 times 2. So what I want you to do is once we get into negative exponents, think of it almost like the opposite. It's repeated division. I'm just going to keep dividing as I go, dividing by 2, dividing by 2, dividing by 2. I'm taking that whole number and I'm cutting it in half. And it depends, again, what number I hear. That's why I say 2, because it's the base. But let's look at here, like look at the pattern. Like if I go from 16 to 8, what am I doing? When I'm going from 8 to 4, from 4 to 2, from 2 to 1, you'll notice that you're dividing by 2 every single time. So you can predict that this next number is, based on our patterns, 1 divided by 2. 1 divided by 2, well, that's 1/2. Think a fraction is 1 divided by 2. That fraction bar is really a division sign. Now think if you were to divide that by 2, think what you would get. And I can even type it in my calculator. 1 divided by 2, that is 0.5. If I push math, enter, enter, if I want to convert that to a fraction, that's 1/2. Well, what if I took that and I divided it by 2? I get 1/4. That's going to be my next answer. Or also, I want to show you, I want to write something. 1 over 2 to the second power. I'm going to try to make that a little bit easier to read. That's 1 over 2 to the second power. Oh, that didn't look any better. That's okay. You don't even. Which is 1/4. Now divide that by 2. So if I go over here, divided by 2, I get 1/8. Well, that is actually 1 over 2 to the third, which is 1/8. So now you can see what I'm doing here. I want you to look at this pattern, see how it goes from 2 to the it goes 2 to the -1, and then it brought it down into the denominator and made it a positive exponent. Here I'm taking this -2 to the -2, I'm throwing it down into the denominator and making my exponent positive. 2 to the -3rd, I'm throwing it down into the denominator and making it positive. That's what I did up here. See how I took this negative exponent, this power, and I threw it into the denominator, put 1 over it, and then made my exponent positive. There is some, okay, so that's kind of what we're going to do for the answers. I'm going to do like the kind of the shortcut way of doing it. But there's another explanation if you're still like aren't convinced why this works or what the point of negative exponents is. I mean, it's really just all about simplifying and a way to simplify our answers. But if we go back to the quotient of powers property, which said that if you have the same base, you can subtract the exponents, you can see here 2 to the second divided by 2 to the fourth. Well, same base, you can just subtract your exponents. We get 2 to the -2. If you want to think about that in terms of expanded form, you can think of it like this: 2 squared divided by 2 to the fourth. That's 2 times 2 over 2 times 2 times 2 times 2, which you'll see you've got 2 on the bottom and 2 on the top, so they'll just cancel. But that doesn't mean our answer is just 2 times 2, because it's still in the denominator. It's actually 1 over 2 times 2, which is 1 over 2 squared, which is 1/4. Okay, I feel like I'm kind of saying too many 2's here. But basically, I think big picture is you're just going to take, what you're going to do is you're going to take 2 to the -2nd power, and you're going to take this entire power and you're going to throw it into the denominator and make it positive. That's what you're going to do on your homework. That's how they want it in that form. They want you to rewrite these using positive exponents. So on your homework, you're going to have to do it this way. Just make it a fraction and then make the exponent positive. So I know that was a lot of talk, but or explaining why, but I hope you just understand that negative exponents are really repeated division. So it's just making a fraction, like a smaller fraction every time it's a bigger exponent, or bigger negative exponent. So like here, 8 to the negative 2, it's like I'm taking 8 and I'm dividing it. I'm like dividing it by 8, dividing it by 8. So we get then like the quicker shortcut way is I'm going to take this 8 squared, 8 to the negative 2, and I'm going to throw it into the denominator. This is going to become 1 over 8 to the positive 2. A lot of these answers want it to be in that form. So like that would be your answer. If you don't really like that, you could simplify that. That's 1/64th. And if you want to prove it on your calculator, 8 caret negative 2, that is this really small decimal. If you go math, enter, you can see, oh yeah, that is 1/64. So it works out. Okay, so then you're just going to take all of these negative exponents, simplify it using a positive exponent. I'm going to create them all into fractions. So I'm going to throw them all in the denominator with the numerator of 1. 2 to the negative 4th is going to become 1 over 2 to the 4th. I'm just taking it, throwing it into the denominator. 3 to the negative 5th is going to be 1 over 3 to the positive 5th. Don't forget to make that exponent positive. Some common errors are people leave it negative and then they just get it wrong. Oop. Okay, let me go back. 7 to the negative 6th, that becomes 1 over 7 to the 6th. You get the idea. So 1 over 9 to the 12th. Remember, you can always use your calculator to prove it. I mean, for example, 1 over 9 to the 12th. 9 to the 12th is, okay. Ooh, this is a good example. We're going to talk about this on Friday, scientific notation. This little e is going to be for scientific notation. It's going to be 2.82 times 10 to the 11th power. We'll learn about that later on Friday. Okay, here I have my denominator. I'm going to throw it down there, make it positive, and then I have my final answer. Okay, so we are done with notes for today. You can go ahead and write your summary, write 2 sentences. In this lesson, I learned, the notes explained how, use your own words, revisit your notes, use vocab that we just went over. The main thing we talked about were the zero exponent property that said any number except for 0 taken to the 0 power is going to be 1. So 1,000,000 to the 0 power is 1. 0.2 to the 0 power is 1. Any kind of number except for 0 is 1. And then negative exponents, think of negative exponents like repeated division. It's just going to become a fraction. It's just going to become a smaller and smaller number the more you divide. So like take that negative exponent and then throw it into the denominator 1 over that and make the exponent positive. Okay, that is it. So go ahead and do your 1-7 Math Excel quietly at your seats. Independently, if you finish early, you can work on missing assignments or your digital choice board. And I will be back tomorrow. Have a good day. Bye-bye.